Low Budget Physics by Mike Torres. Now, what we're going to learn today is how different angles determine different distances and peak heights of projectiles. Now what I did, I made 5 little paper footballs. 4 of these paper footballs we'll put to the side real quick. Each one we're going to launch, or I guess you could say flick, at a different angle. Now we're going to have a 0 degree, 25, well actually we're going to make it a 22.5, a 45, and 90 degree angle. Now, how we're going to determine the angles is we're going to use a normal piece of paper. Now, we're going to say, how can this determine or measure angles? Now, from the ground up, you would say that is a 90 degree angle. Now, what we could do is fold it in half. Now, if you cut a 90 degree angle in half, you would get a 45 degree angle. So, this we're going to use to measure our angles. So we first had the 90 degree, the 45 degree, and now what we're going to do is we're going to fold it once more in half after a 45 degree angle. And then we're going to try and go as horizontal as possible. Now on that wall, you may not be able to see, but I put pieces of tape up and measured how high they go up. Now the highest it goes is 5 feet 6 inches, and we're going to see if we could hit the closet at what measurement. Now what we're also going to use are distance formulas. So we're going to use distance in the y direction and x direction. Now, what we're going to do now, this will be hard, but we're going to launch one of the projectiles 90 degrees up as possible. Alright. So first we learned that it'll go straight up and straight back down. So, first mistake that someone will do is they're not gonna see how far it goes, or not how far, but how fast it'll go. How we're gonna do that is we're gonna measure the time it takes to go from our launch point to the closet, and then we'll use the velocity formula. Now we're going to flick it, and you could say it hit the closet in around 1.5 seconds. Now for velocity, we'll use the formula v equals distance over time. Now, v will equal 12 feet over, I would say, around 1.5 seconds. Now, we are going to take out our calculator, and we'll do 12 divided by 1.5 will equal about 8 feet per second. So our velocity equal 8 feet per second. So that would be the first thing you would want to use, because our two formulas will be dy equals VIY t plus 1/2 AYT squared, and dx equals VIXT plus 1/2 AXT squared. Now, we have our time and our velocities. Now, you're going to say, what about distance? The distance I used, which was 12 feet, was just a test run to see how fast our projectile will go. Now, we are going to launch the first projectile as horizontal as possible without any angle. Now, you would say probably landed 11 feet from here, but you can never be too safe, so we'll measure it. And it was 11 feet exactly. Now what we say with our first projectile, projectile 1, our angle was 0 degrees. Okay, so at 0 degrees, we need to find our distance in the y direction, in other words, our peak height, and distance in the x direction. Now, for our y direction, our velocity initial is already 0. So this whole thing is 0. So we're more focused on this. Now, to find acceleration in the y direction, or AY, is A sine 0. So go on our calculator and we'll do 8 sine 0. Oh. And if you would think, this whole thing cancels out to be 0. Now, if we plug it in, so we'll basically just do dy equals half of 0 t squared. Now, you already think, if we launched it at a 0 degree angle, peak height will be 0. Now, we'll do dx equals VIX t plus 1/2 AXT squared. Now, dx equals 8 times 1.5, which will equal 12. So now, at a 0 degree angle, our projectile will have a peak height of 0 and a distance in the x direction of 12. Now, let's do an angle of 22.5 degrees. here's our angle, 22.5 degrees, as you can see. Now, what we're going to do, set the camera down. Here's our angle. And we are going to launch it off this angle. Now, each time I flicked it, it's not going to be the same exact force, which will cause different velocities. But that's why we used a starter velocity, because all these projectiles I'm showing you are more for demonstration. That's why it's called low budget physics. Now we're going to use the same formulas as before. AX equals 8 cosine 22.5, AY equals 8 sine 22.5. Goes back to our calculator. So we'll do 8 cosine 22.5. I don't know why this calculator is messing up. So let me get another low budget calculator. Now, we will do 8 cosine 22.5 equals I have found the AX and AY. So AX will equal 22.1, AY will equal 3.131. Now, here are equations. So, AX wouldn't really matter for finding the distance in the X direction, or the X displacement. Now, that's what you would think. But we have to find 1/2 AX t squared, which will equal 1/2 2.1 times 2.25, which will equal 24.8625. Now, distance in the y direction should basically do 1/2 AY times t squared. So, this is not our answer, but we will do 3.131 times 2.25. You will get 7.04475. Now we have to divide it by 2. You would get 3.522. Now, we have to find the projectile of the third one, which will equal 45 degrees. So, just take our angle, and this is our 45 degrees. So, we will have another demonstration. Now, same thing. AX equals 8 well, no, AY equals 8 sine 45, a cosine 45. Now, had a little mountain function before, so what we do is 8 parentheses cosine close parentheses times 45. Now equal 44.56. Now we find our y. So we'll do 8, 5, 8 sine equals 6.262. Now, dx equals vixt plus 1/2 a xt squared. Now, we'll do dx equals 8 times 1.5, which is 12. Then we'll do 1/2 44.56 times 2.25. So we'll do 44.56 times 2.25 divided by 2. That'll be 50.3, or 50.13. So we get 62.13. Now, distance in the y direction will equal Vix t plus 1/2 a t squared. This will cancel out because there's no velocity in the y direction. So we get 1/2 a y t squared. So you get 1/2 ay equals 4.524 times 2.25 equals 10.9, or 10.179 divided by 2 equals 5.0895. So dy equals 5.0895. Now, I feel like for the 90-degree projectile, I don't need to show a demonstration because it will not go anywhere in the x direction because it's going straight up. If it goes straight up, it will go straight back down, and there's no angle in the x direction. So dx will in fact equal 0, but we can find dy. dy will equal velocity in the y direction, which is 8t, which is 1.5, which will be 12, plus 1/2 a y t squared. Now, acceleration in the y direction will be 0 because it's going straight up. If it was going down, it would be 9.8, which is not. So, right here will be your answer. dy will equal 12, which will be its peak height, which will be also its maximum peak height.